Question number 8 has again recurred from current electricity, and it's related to a circuit. A circuit has been given here, and the current in 1 ohm resistor is, we need to calculate the magnitude of current as well as direction. This particular circuit can be simplified by using the combinations of cell. Like particularly, this circuit can be thought or can be redrawn in this way. That's 6, that's 3 ohm, this is 1, and here comes 9 volt, and 2 plus 3, that would be 5. Now we need to calculate the current across this. So this and this can be taken in parallel, which is E1R2 plus E2R1, but this time that would be minus because the polarity are opposite. So E1R2 is 27, E2R1 is 30. So this is the winner. So the polarity would be dominated by this. So that's E1R2 30, I'm taking this as positive, minus E2R1 27 by R1 plus R2, that's 5 plus 3, 8. So the overall equivalent EMF comes out to be 3 by 8 volt. That's equivalent EMF. How about the equivalent resistance? These two are in parallel, so that would be 15 by 8. So we've already said this one wins in terms of polarity, so I can finally redraw in this way. This is 1 ohm and 15 by 8 and 3 by 8. So quite obviously, now the current would go in this way, and from here that would be for Q to P. So quite obviously this has already been solved. Now we need not go because the second and third option is from P to Q. I have only one option from Q to P. However, if we calculate the magnitude, that's EMF by the net resistance, that will lead us to option number A. So let's proceed to question number 9, and this one was the option for question number 8. Question number 9 is from wave optics, and particularly it has been taken from the portion where we deal with limit of resolution. Assuming human pupil to have a radius of 0.25 centimeter. So let's read the question first. And a comfortable viewing distance of 25 centimeter, the minimum separation between two objects that human eye can resolve at this much wavelength is. So this has to deal with diffraction and particularly the Rayleigh criterion, where Rayleigh had given the criterion for distinctly resolving two different objects. So this is my circular aperture, and the radius of that circular aperture is R. And we know that two objects are just resolved or barely resolved if the diffraction minima of one just coincides with the center maxima. So this is the situation. These two locations are the locations of 2-point objects, and the respective disks are their disk of first maxima or central maxima that we call as the airy disk. So for this, if we call this angle to be theta, then Rayleigh criteria says sin theta is 1.22 lambda by d, where d is the diameter of the circular aperture. In our case, that's 2r, and this is capital D, if I say, the separation between the eye and the objects, and delta x is the separation between the objects. And in this particular limit, sin theta can be taken as theta, and that will be equals to delta x divided by d. So with this calculation, if you go and solve, you would see minimum separation between the two objects, that's delta x, would lead you to option number D, that's 30 micrometer. Now let's proceed to question number 10. Question number 10 has been set up from RL circuit, and this comprises of both the charging and discharging. The resistance is given to be 0.15 kilo ohm and inductance 0.03 Henry. Be careful, here is a kilo. K1, K2 are the two keys. K1 is closed for a long time. So initially when K1 is closed for a long time, the current through the inductor, if I denote it by I naught, that I naught would be E by R since it's shorted. So that's 15 by 0.15. This is in kilo, this is in volt. So the total current would come out to be 100 milliampere. I'm doing in this way because I can smartly see that the options are in milliampere itself. Now what happens at t equals to 0, K1 is open and K2 is closed. So now this becomes RL discharging circuit, and we got to calculate the current at 1 millisecond. So first of all, let's calculate the time constant during discharging. That comes out to be L by R, and L is 0 or 0.03 and R is 0.15. Again, this is in Henry, this is in kilo, so that's simply going to be 1 by 5 millisecond. And we need to calculate at t equals to 1 millisecond. So this time t by tau, that is going to be 5, because the time is 1 millisecond, time constant is 1 by 5, so that's a simple calculation. So I've got everything. Now all I need to do is that I need to plug it, e raised to the power minus t by tau, and e raised to the power 5 is given. So this is a simple calculation and it would lead to option number 2. So that would be the correct option for question number 10. Let's proceed to question number 11.